Welcome back. We are still working on solving variables and plugging things in. So the next one we're going to do, I want you to take the remaining space that you have and split it into fourths. So we're going to split this one in half and then go in half the opposite direction. Then I want you to outline those lines with your blue crayon, aqua blue. This will make sure that we can get 4 more practice problems in. So however small you need to write, you need to have 4 more problems written on here. So you might have to write a little bit smaller than what you're used to. Okay, the remaining 4 problems have to deal with the order of operations, which is Pemdas. We're going to say the fun saying for Pemdas right now together. Please excuse my dear Aunt Sally. That's correct. So that means there's going to be more than one operation, and you have to do them in the correct order with a variable. So we're just adding a layer of complexity. Complexity. That's the word. Okay, ready? 50 minus n divided by 2. And then they're going to tell us 4, which means the word 4, n is 30. They're going to tell us that. So we have a couple different things here. First, they're checking, do you know the order of operations? And second, do you know how to plug it in, plug it in? That's what they're checking. So I first can plug it in, or I first can decide what happens first. It doesn't really matter. I think I'm going to do Pemdas first. So just up here on the top right, will you please write all capital letters, Pemdas. Remember that M and D are connected and the A and S are connected. Multiply and divide and then add and subtract. So when I'm looking at this situation, I have 2 different operations. I have subtraction happening and I have division happening. So which one of those comes first in Pemdas, is the S or the D? It's the D, and they're not connected, so I do the division first. This is what we were talking about yesterday, when we can take our crayon and insert our own parentheses. We can automatically go, you know what, I know division has to happen first, so therefore I am going to add my own parentheses. It helps my brain recognize that's where you start. So add your own parentheses, and then you're going to need to plug it in, plug it in. So the 30, watch this, gets plugged in as the n. I am going to rewrite the problem to the right, staying in this box. The problem now says, I'm just going to come maybe right here. It now says 50 minus parentheses 30, because I plugged it in, divided by 2, close the parentheses. That is what the problem now says. This is when you have to know how to do carets. A caret is just a math symbol. Looks a little bit like a bracket or the tip of an arrow. And I'm going to solve that first and then do the other operation. So 30 divided by 2, does anyone know what 30 divided by 2 is? Go ahead and tell me number 17. 30 divided by 2 is? Not sure? All right, go ahead and tell me what 30 divided by 2 is. Number 13.
30 divided by 2 is 15.
I love the way you said that. You can grab a stamp. She repeated the problem. 30 divided by 2 is 15. So we put underneath the caret 15. Then we bring down anything that's still there. So the subtraction sign is still there and the 50. So the problem now is 50 minus 15. And that can sometimes be done in a head, like mental math, but for some of you who are struggling with subtraction, you just stack it up and do 50 minus 15, and you're going to get your answer pretty quickly. The answer to this problem, this expression, because it didn't have an equal sign, the answer to this expression is 35. So they're saying if n was 30, then the answer to this whole problem is 35. Let's see what would have happened. Do some little slashes here. What would have happened if I didn't do the order of operations correctly? Let's see what we would get. Okay, Let's see what answer we would get. So if I did not do it correctly, it would look like this. 50 minus, and then plug it in, n was 30, so plug it in. And you still have the divided by 2. So let's say I didn't know my order of operations. And I just went, well, I'm just going to go left to right because I don't know which one should come first. If you didn't know and you just solved it left to right, this answer would be different. 50 minus 30 is 20. And 20, draw this connecting line. And 20 divided by 2 would be 10. Is 10 the same answer as 35? No, very different. In fact, if I said to you, you have 10 total self-starts to do this week. Or if I said, you have 35 total self-starts to do this week. Very different. So that is not correct because it did not follow the order of operations. Not correct. Order of operations is not just some magical thing we ask you to do for math. There's a reason why we do it, and it has to do with the importance and the value of the operation. Which one has more importance? Okay? All right, next problem. You guessed it. We're going to be doing another Pemdas problem, so you can write it again. There's going to be more than one operation, and you have to determine which one is supposed to be first. And we're going to begin it with, sure. Should we make it super complicated? Yes, let's.
No.
Let's make it complicated. Ready? A, so there is the variable right away. I think I'll do it right here. A times 1/3 plus a big 3, a whole 3, divided by, ooh, there's lots of things going on, a 1/3. Wow, lots of things are going on here. Let's locate the 3 different operations. Starting from left to right, we have multiply, add, and divide. So over here in Pemdas, I had an M, the A, and the D. I have an M-A-D. It's mad right here, M-A-D. Okay? Which one of those should come first? Multiply, add, or divide? Multiply. However, what if the division sign would have been on the left over here? It would be divide because it's whichever one comes first, left to right. Let's go ahead and underline the M and D. It's just whichever one comes first. And in this case, did the multiply come first or did the divide come first? The multiply did. So that's the one that you begin with. So what's crazy about this is I have to put in my own parentheses. I go like this. Okay, that has to happen first. And I'm going to solve that problem. What can I not do yet? How do I solve this problem? I cannot solve this problem. What am I missing? What do I have to know? There's a piece of information missing in order to solve that problem. Thank you. There's a lot of people who think they know. What piece is missing? Number 17.
One number is missing, so you can't do it because you have to have 2 numbers.
Correct. What do I need to know? I need to know what A is. Otherwise, I can't solve that, right? So let's come up here to the top, and I'll tell you what A is. A is going to equal 3. So up at the top right, A equals 3. Okay, now I go like this. Plug it in, plug it in. Plug that 3 into this problem. So I'm just going to kind of put it like this. This problem now says 3 times a 1/3. That's what it says. Plus 3, you still have to keep everything else, divided by a 1/3. It's kind of like doing a wiki where you're just plugging it in, you're moving on. Okay, now we solve this one with a caret. 3 times a 1/3. This means 3 groups of a 1/3. So I have one group of a 1/3, one group of a 1/3, and another group of a 1/3. That's 3 groups of 1/3. That's what that means. If that's too confusing for you, you can always just multiply straight across. But the answer to this is going to be 3/3 or 1 whole. So 3 groups of a third means I'm going to get 3/3, which is equal to 1 whole. Crazy, huh? I'll just put off to the side 3/3 equals a whole, just so that that's not too confusing. And if you're like, what? I don't like that. Just do 3 times 1 is 3. And what would you have put under the 3? A 1 to multiply. And a 1 times 3 is 3. That's how it worked. And bring everything else down. So I now have, I'm just going to wiki the 3/3. I now have 1 plus 3 divided by a third. And sometimes this is when 5th graders get to this point and they go, oh, I can do that. 1 plus 3 is 4, and 4,
No.
you're still doing PEMDAS. You still have 2 operations. Guess what? Add does not come before divide. It comes after. So we have another set of parentheses. That's great that we figured out 1, but we don't add yet. We're supposed to do the division next. So I caret this one. To divide by a fraction, here's a tip. Keep, change, flip. So that means over here I kept the 3, change divide to multiply. How do I flip 1/3? 3/1, which just means 3. So inside of these parentheses, everybody is 9. Good. Bring down what's left. Still have the plus sign. I still have the 1. My answer to this crazy problem is 10. And I promise you, if we would not have gone in the right order, we would get a very different answer. You have to go in the right order. Look how much work that was. Plug it in, solve, bring down, figure out which one to do again, solve, bring down, combine. Lots of work on the math today, lots of work. Okay, the next 2. These ones won't be so much of PEMDAS as it is just going to kind of be some complicated problems. Okay, here we go. I want you to solve this problem.
Teachers
We'll
and
wait till the
students,
announcement's
it
over.
will be an inside date.
Okay, ready? The letter H divided by 0.07. I cannot solve this unless they give me the answer or if they give me what H is. So this is called an expression. It's missing something still. Okay? So I'm just going to tell you H is 49. Okay. Then I take this number. We'll just put like a little cloud around it. And I, sing it with me, plug it in, plug it in, plug it in. So this problem now says 49 divided by 0.07. Again, we get people who stop right here and go, I don't know how to do this. Yes, you do. You simply remember that, oh yeah, division means I'm going to be drawing this box that looks like a division box. I actually don't want to put it right there. And some of you probably know why. I'm actually going to put the box over here. 49 divided by 0.07. Some people think, oh, that one's longer. It automatically goes in the box. No. Remember the problem. The first number is the dividend. 49 goes in the box. That's the first number. 49 divided by, you work backwards, divided by 0.07. Wow. So now I have 49 divided by 7 hundredths. Well, you have a decimal out here in the divisor, you have to get rid of it. That was moving it 2 times. I'm not even going to put 10 to the second, I just put 2. So how do I move this decimal 2 times? Where is it? And can you explain it clearly? Can you explain this for me? Number 10.
The decimal's behind the 9, so you have to add zeros. You have to add 0 for every place value, which means you have to add 2 because it's 10 to the second.
That was very well explained. Thank you. You can get a stamp later. So number 10 said the decimal is here at the end, and I have to move it 2 place values, and you fill in zeros for place values. So this number is now not just 49, but it's 4,900. So I'm going to rewrite this problem because when I moved this one twice, it changed it to 7. When I moved the dividend number, the decimal twice, it changed it to 4,900. I wouldn't put in commas because they're not necessary when you're just doing the work. And now I solve it. This does not say 7 divided by 4,900. It does not say that. It says 4,900 divided by 7. So this is pretty easy actually. I'm going to let you mental math that one because 7 goes into 49 exactly 7 times, and then there would be 2 zeros. So the answer to that problem is 700. Guess I'll just leave it on the division bar up there. 700. Okay, last practice problem in our journal. Ooh. Here we go. Let's make it a good one. Oh yeah, that's pretty tough. X times, notice how when we do X as the variable, I don't put a little x for the multiplication. That would look really confusing, right? Big X, little x. You just do a dot if that's the case. So X times, I want a mixed number. Let's do 1.5. That's a mixed number. And I have to tell you what X is. Otherwise you can't solve this problem. Okay? So I'm just going to tell you. X is, think about it, 10. I'll give you a good number. X is 10. Plug it in, plug it in. This new problem is 10 times 1.5. If you don't get how to plug it in by the end of this lesson, I'm going to make you re-watch these videos because it's simple. You just put the number in the place of the variable. So why is it now 10 times 1/2? Because the x was 10. And now I solved this. I think that some of you really, really know how to divide when it comes to fractions, but you've forgotten how to multiply. And that's interesting because typically the division is harder. So let's try this multiplication. I cannot multiply a whole by a mixed number and just make up whatever I want. I have to do this fun thing we learned a long time ago. Multiply, then add. You have to change it into just a fraction, not a mixed number. So I go like this. 2 times 1 is 2, plus 1 is 3, over 2. How did you know it was over 2? Number 25.
Because the denominator is severed and it stays.
Yes, it does. Come get your stamp. Okay, so it's 3/2. But I'm still timesing it by 10. Who can tell me what the next step is that people forget in a problem like this? Some people look at it and go, Ms. Fisher, that didn't make it easier. That looks harder to me. What do I do next? What do I do next? Number 26. Can you tell me what I do next?
You have to put a 1 under the 10.
Ding, ding, ding. You got it. Come grab a stamp. You have to put a 1 under the 10. Now I'm looking at 2 different fractions. I'm looking at 10 over 1. Anything could be over 1. Anything can be over 1. For example, I have right now 1 over 1 pencils. It's just one whole, right? You can throw a 1 underneath anything. So 10 over 1 is the same as 10. And then I kept my 3/2 because I changed that into 3/2. And now who can tell me what I do next? This is the best part. After I do all that work, what do I get to do, everybody? Multiply straight across. Or, yeah, well, not cross multiply. Simplify, cross simplify. I'm not going to in this case because I just think that's a lot of work, and I'm just going to don't go multiply straight across, and I get 30 over 2. And I know how to simplify that in my head, but if you didn't know how, you could go back and simplify the 10 and 2 first. But I know that 30 over 2 equals 15. So my answer to x times 1.5 is 15. And then I might throw a problem at you and say, great, so you know what that was if x was 10. What if x was 20? That might come up today where you have to, okay, well, what if I choose a different number for you for that? It's the same idea. You just plug in a new number and do all the right math. How many of you know what it would be if I said this was 20? It would be double the answer because it was double the starting point. So the answer would be 30. Okay, good. I'm glad you know that. All right. I wish we were done with this, but we're not. So what I want you to do is make sure that you understand variables are letters that stand for numbers and how to plug it in. Yeah? Right. You're going to need this, but you're also going to want your homework out. So go grab your homework and remembering for 7.3 and turn to the homework side where you'll put your name and number and the date. You need to put the dates here. Okay, if you are leaving out your journal, you're going to see a lot of really similar problems. But I would like to solve one of these problems up top together, and then I would like to solve number 11 together, because that's actually a really cool problem, and I really just love it. So, take a look at your problems numbers 1 through 9 on your homework side, and let's see if someone who's sitting in the class right now could pick a number that's not done in our journal that they could use some help with on the assignment. Glance through it. You get about 10 seconds. All right. Who wants to choose the problem for us? Number 2. Pick for us which problem you'd like us to do.
Number 8.
Number 8. Number 8 it is. I think that's a good call. Okay, everybody focus in on number 8. Number 8 is a Pemdas problem because I have parentheses, subtraction, and multiplication. So up here at the top of my paper, I'm going to write Pemdas. You should too. It just helps me remember what to do. So first thing I look for are parentheses. Are there parentheses?
Yes.
Yeah. Sweet. That's the first thing I do.
Wait.
But I don't know how to solve this if I don't know t. Luckily, they told me t is 0.02. So I'm just going to go like this above it, 0.02. So I'm supposed to take 0.15 and minus 0.02. Or I could say this in a different way. I could say I'm supposed to take 200ths away from 1500ths. That's what that means. How many of you can do this in your head? Think about this. I have 1500ths. I'm taking away 200ths. I'm left with 1300ths. Go ahead and do that. And then you have to still keep the multiplication and still keep the 100. This 4 right here, you don't need this information anymore. We plugged it in. We don't need that anymore. So don't let that confuse you. I oftentimes will cross it out when I'm done plugging it in so I know what's left. Now I'm solving 0.13, and that's a times. That's not a decimal. Times 100. You need to not panic about multiplying things by tens and hundreds, because when we multiply by tens or hundreds, it's moving decimals or adding zeros. That's what it is doing. So I just go like this. Well, how many times am I going to move this decimal to multiply it by 100? It's getting 100 times bigger. Do you know what 100 is? It's 10 to the second power. So I'm just going to underline the zeros to show you. 1, 2, and write a baby 2. There's 2 zeros there. So I get to just take this decimal and move it 2 places. Do I move it backwards and the number is getting smaller? No, I move it forward because the number is getting 100 times greater. So I move it twice, and everybody, the answer is 13. That's not terrible, was it? You did a good job. Okay, the problem I would like to do is number 11. I love this story problem because it's all about finding out ages of people when they haven't given you all the clues. You're going to go on a little investigation right here, trying to figure things out. Anytime we work with a problem like this, we want to keep notes off to the side of things we know right away, because then we don't have to go back and be confused. We use our notes. So we go like this. Luke is 4 years younger than Zoe. Misha is half of Luke's or half Luke's age. Let Z be Zoe's age. Wow, we have Luke Zoe, Misha. Ready? We're going to write these off to the side. We're dealing with Luke. Let's just put an L is equals. We are dealing with Misha, M. We're going to use them as variables. And Z. They say let Z be Zoe. They want you to use Z for sure for Zoe. We just chose the other two to be L and M. I think it would be silly not to choose the letter of their first name because then it's confusing. So L, M, Z. We know that Luke is 4 years younger than Zoe. So we know that L is Z, Zoe's age, minus what? Luke is 4 years younger. So it's minus? No. This is Luke. Luke is Zoe's age minus 4. Minus 4. You guys are not looking at the text. Luke is 4 years younger than Zoe. That means it's Zoe's age minus 4. Let's say Zoe's 30. Then Luke would be 30 minus 4? 26. That's what it's saying. Okay? So I don't know any numbers. I don't know what these letters stand for yet. I just know that Luke is Zoe minus 4. That's what I know. Let's find out what we know about Misha. Misha is half of Luke's age. Misha equals 1/2. How old is Luke? Do we know?
No.
So what do we use? Yeah, we use a variable. And we put it right next to the fraction because that means of times. So we know that Luke, is Zoe's age minus 4, and Misha is half of Luke's age. What do we know about Zoe from this story problem? Nothing. Misha is half Luke's age. Let Z be Zoe's age. No idea what Zoe is. Question mark, no idea. Later it's going to tell us, and we're going to start to plug it in. But right now, before I read ABC, do I know anything about Zoe? No. Do I know anything about Luke? Yes. He's 4 years younger than Zoe. Do I know anything about Misha?
Yes.
Yeah, she's half of Luke's age. Great. Glad you know that. Let's move on. Letter A. Write an expression, that means don't use an equal sign, for Luke's age. Oh, Z minus 4. That's it. Don't put equals. They don't want an equal sign. They would have said equation if they wanted that. Next, B. Write an expression for Misha's age. 1/2 L. Could you do it like this? 1/2 times L? Could I do 1/2 times L? Yeah. Could I just put the L right next to the 1/2? Yes. Could I write the word of? What do you think about that? I can't actually because it's only numbers and like symbols. I can't use the word of here. But it is of in my head. It's what it is. Okay. Letter C. If Zoe, now we know. If Zoe, everyone draw this arrow. Plug it in. If Zoe is 16, I'm going to use my blue. You should too. If Zoe is 16, then how old are Luke and Misha? Okay, they give us one piece of evidence, and now we have to backpedal and go, okay, plug it in. Guess what? I cannot solve Misha's age right now because I still don't know L. So I have to find out L first. So I plug it in. 16 minus 4 is 12. How old is Luke, everybody? 12. So that's the first part of the question. How old are Luke and Misha? Luke is 12. And Misha, don't answer it out loud. And Misha is, I don't know yet. Luke is 12. And Misha is, now that I know Luke is 12, I take his number. Look how cool all these notes are. I take his number and I plug it in. Plug in 12 for Luke's age. How old is Misha? What is 1/2 of 12? Let's just write it right here. What is 1/2 of 12 for Misha? 6. Misha is 6. Period. That was a really cool problem that you had to work backwards for. And you had to keep notes to figure this stuff out. But the expressions were our notes. Did you catch that? The expressions were what we had written before. So, what if I told you that Zoe was 20? Hold on. Let's write it off to the side. If Zoe is 20, then I really do want you to find me these two numbers. Then Luke and Misha. This is why you have to watch the videos, because you get extra points for this kind of stuff. All right. If Zoe's 20, plug it in. Figure it out. So instead of this number being a 16, make it be a 20 just in your head and go, okay, instead of 16 minus 4, it would be 20 minus 4. How old would Luke be? What's 20 minus 4? 16. And Misha is half of Luke's age. So how old is Misha? In this problem, Misha would be 8. That's pretty cool. Does that make sense to everybody? You can always take a number and plug it in. Pretty awesome. Number 10, you do not need to put an equal sign, so make sure you don't. It says expression. And then B, then they'll give you the information. If this, then how much did he spend? So you're going to have to figure that out for yourself. Be really careful. If he's doing, I'll just do this with you. Max bought a pair of jeans for $32 and 3 t-shirts for $T each. I'm going to circle that. 3 t-shirts for $T. That means I don't know how much money the shirts were. I do know how much the jeans were. So I'm going to just say it's asking total, how much did Max spend, like on A. So I know he spent $32 plus, I should put the dollars in. I know he spent $32 plus whatever the t-shirts cost. He bought 3 t-shirts and they were all the same amount. What operation is that? Are you dividing? Are you multiplying? Multiplying is right. Way to say that. It's multiplying. So you have to be able to do 3 times T. I just don't know what the t-shirts cost yet. What would you do in this expression to prove to the person grading it that you know which of these comes first? Add or multiply? It's multiply, but how do you prove that? How do you prove you know that, everybody? Parentheses. You put those in yourself. Don't put equals. I don't want an equation. I want an expression. And now they're telling you if each t-shirt, or if that T, I'm just going to go like this with an arrow, is $9, how much did Max spend altogether? You're going to get to solve that on your own. So thanks for joining me on math today. You get